Hello, I'm John Oliver. I'm a technical director at Sparkbox. Been with Sparkbox for about 8 years now. Been doing web development for almost 2 decades, which makes me start to feel old when I say it out loud, but that's okay. And with me, I have Dustin.
Yeah, hi, I'm Dustin, another developer at Sparkbox. I've been here a little over 4 years, and I spend a lot of time thinking about how best to build websites. So hopefully that is clear in the talk.
So today we're going to take a closer look at the modern web development landscape and in particular React's role in it. We'll explore what problems React was designed to solve, where it continues to shine, where it causes friction, and how modern web standards and alternative tools are shifting the equation. So, if you've worked in web development for more than a few years, you've probably seen the front end development landscape evolve dramatically. We've gone from jQuery hacks to fully reactive apps, and we've come a long way, but we've introduced new challenges and trade-offs in the process. So, React has emerged as a solution to the chaos of early dynamic UIs. It offered structure and clarity where things got messy, and it did a pretty good job of that. And it really took off because it solved real problems with a fresh mental model. But over time, the front end landscape has changed, the platform has matured, and now a growing number of developers are asking, do we still need React for everything? In some cases, you might, in some cases, you might not. So, this talk isn't about choosing sides, it's about understanding the trade offs. When is React the right tool? When is it overkill? What can we accomplish with modern browser APIs and lighter frameworks? And what should we reach for instead of React when the complexity doesn't justify the cost? So, here's what we're going to talk about where we came from, where we are now, if not React, then what? If React, then how? And some final parting thoughts. Uh, so first, let's start by rewinding the clock and looking at the problems React originally set out to solve. So if you've involved in web development for long enough, you may remember the days before React. A little buzzword called Web 2.0 had taken hold, and the bar for user experience and interactivity on the web was rising higher. Websites that were once static were becoming applications in their own right, and technologies like Ajax and jQuery were being used to provide more seamless user interactions. Instead of full page reloads to respond to user interactions and show new info, data was starting to be fetched under the hood and rendered to users on the fly and providing more interactive interfaces. So these development allowed us to build better experiences for our users, but they did introduce a bigger challenges for developers. Complexity. So user expectations grew, which meant that business requirements grew, which meant that the complexity of our applications grew with them. And with this growing complexity, different approaches to building these types of highly interactive web applications started to emerge. Now, some of these approaches were all right, but many of them left room for improvement. For example, a common approach in the early days was a nice big plate of spaghetti. JavaScript was used to fetch data from the server and then update the info displayed to users by injecting new data into the DOM using targeted updates. So here's an example of what that used to look like. So this is a simple example of fetching a list of users to display. In our HTML, we have an empty div that acts as a container for our user list. Then we have some JavaScript to fetch and display the user data. So first, our function grabs a reference to the container div and adds a loading class so that we can show a fancy little loading spinner. Then we fetch data from an API endpoint. Of course, we're using jQuery here for maximum historical accuracy. After fetching the data, we create an unordered list and then loop through the user data to append the list items for each user. After that, we inject the list into our container div and finally remove the loading class. So while this worked fine for pages with minimal interactivity, it quickly became unwieldy when managing pages that required data fetching from multiple sources or updates to multiple places on a page. Developers had to determine their own patterns for handling application state and make making updates to the DOM based on when that state updated. So this resulted in a lot of spaghetti code with no clear flow of data, and often resulted in discouraged patterns like using class names or other things to store application data or application state. And the result was that as complexity grew, DOM updates were harder to coordinate and synchronize, and updating existing code without breaking things became challenging. So where do we go from here? Well, many developers started to adopt templating libraries in order to make DOM updates more declarative and easier to understand. Some of the most popular templating libraries were Mustache and then, of course, its successor, Handlebars, but there were others as well. So let's take a look at what that looked like. So again, we have our container div for our user list, but this time we have a template defined in a script tag. So this is better than the previous example because it uses a declarative syntax for rendering our HTML, which makes it easier to read, write, and understand. It also helps us to separate our rendering logic from our data fetching logic. Now in our JavaScript, we grab and compile the template with handlebars, and next we call our refresh user function, which behaves pretty much the same as our previous example, only instead of building our user list with jQuery, we are just populating the data in our template and rendering that template to our container div. And then finally, we remove the loading class again. So this solution was a little better, but it still had some drawbacks. Re-rendering entire templates, decreased performance compared to targeted updates. You can see in the example where we're still adding and removing the loading class manually with JavaScript. And sure, we could add conditional logic in our template to determine whether or not to include the class, but then we'd be re-rendering and re-injecting the whole template multiple times for a single flow. So we'd often do the initial rendering of the template, then make targeted updates afterwards with JavaScript. And it was largely up to us as developers to determine what parts should be rendered with the template and what parts should be manual DOM updates, which of course resulted in inconsistent rendering patterns across code bases. Also, we still have the question of how to properly manage state when the data was updated. Developers were often still rolling their own solutions, which typically didn't scale well and tended to change across projects. So there was still room for improvement here, which brings us to the first wave of reactive frameworks. So as complexity increased, a wave of frameworks emerged like Knockout, Backbone, and AngularJS, the predecessor to the Angular we know today. Uh, these frameworks aim to bring more structure to front-end development. Now, I'm not going to show examples of all of these, but I do want to talk about a few of the benefits that these tools were starting to introduce. They introduced patterns for tracking and updating application state and they were able to automatically update the DOM when state changed, and probably most importantly, encouraged a separation between data and presentation. So these were all good improvements from the previous examples we looked at, but while they moved the ecosystem forward, they still came with their own trade-offs. So many of these frameworks use two-way data binding, which means that changes in state automatically update the UI, and vice versa, changes in the UI automatically update the state. So this sounds great, but it often led to implicit state, meaning that state was changed indirectly through the UI without a clear, explicit trigger in the code. And these updates made it harder to trace how and why the UI changed. Additionally, performance became an issue as apps grew with inefficient DOM updates and change detection strategies. And debugging and maintenance were challenging as well due to unpredictable flows of data and side effects. Ultimately, manual structure and conventions were often required to keep these code bases from devolving into chaos. So React emerged as a response to some of these issues, as well as some of the issues that we previously looked at, and it offered a slightly different mental model. So React used one-way data flow, uh, and that made state changes more predictable and easier to debug. Instead of the UI directly modifying state or relying on automatic syncing, like with two-way binding, with React, there's a one-way data flow, and updates happen through controlled intentional events. Next, React's form of declarative rendering removed the need to manually update the DOM and was able to make very targeted updates through its internal reconciliation process. Uh, and React's rendering mechanism also used plain JavaScript, so you didn't have to learn and rely on different bespoke templating syntax for control flow things like conditional rendering or looping through collections. Finally, and probably most importantly, React introduced a simple component-based architecture and HTML-like syntax that made UIs more composable, testable, and scalable. So let's take a look at our previous example one more time, but this time with React. So here we have a user list component where we're using a couple of useState hooks for getting and setting our data. And so when we fetch the data, we're just calling the set methods for state. Um, and finally, we return a little bit of JSX that uses the state to render the component. So at first glance, this example might not appear to be that much better than the previous examples, but there are a few important things to call out that React gives us. First, it gives us a pattern for getting and setting application state, and it gives us automatic DOM updates. So we're no longer concerned with manually injecting data into our DOM. We just fetch the data, set it in state, and tell React how to render based on that state. So ultimately, React didn't just offer new tools, it offered a simpler, more robust way to reason about UI in the face of growing complexity. With that, adoption of React started to take off, and it seemed like React had really hit a sweet spot between traditional templating and the more advanced frameworks that were emerging. It was simple enough for teams to easily adopt and become productive with, but robust enough to handle the needs of modern web applications. Of course, in the meantime, web standards were continuing to evolve and improve, and starting to address some of the shortcomings that made React popular in the first place. So now I'm going to go ahead and hand it over to Dustin to talk about some of those improvements.
Yeah, thanks, John. So that brings us up to where we are today, and let's start by taking a look at where React's at these days. Uh, so as John established, it does solve a lot of the problems that we used to run into, but React also introduces some new problems. If you've worked with it for any length of time, you've probably encountered some of the following issues. In React, every component requires a single element to contain the markup for that component. And while fragments exist, they're pretty underused, and most of the time that wrapper element ends up being a div. And when lots of components get stitched together to build a page, you end up with div soup. Like in this code sample, which is lightly edited but pulled from a real website. And while this isn't inherently problematic, you can see that when you have automatically generated machine-friendly class names, it gets kind of hard to troubleshoot. Like, why is the alignment off? Why is the wrong color being applied here? It just gets a lot harder to dig into the inspector and figure out why styles are broken or even what components are being used. React also has some performance problems related to doing extra work. For example, client-side React uses a virtual DOM to figure out what needs to be changed before making the actual change in the real DOM instead of just updating the DOM directly, right? Like it's doing the same thing twice. Pure overhead, in other words. Likewise, Next.js runs application code on the server to stitch together the HTML response. And once that lands in the browser, it does all that work again to re-render everything and wire up interactivity. And if something goes wrong during that step, the perfectly functional HTML that was already rendered might get replaced by an error message. This is called hydration, and that's a big part of why you might need to wait a few seconds after loading a page on your phone before any of the buttons work. There are also a lot of rakes to step on with React's API, by which I mean subtle, easy to make mistakes. In this 20-line code sample, there are at least 5 different issues. Can you spot them all? Write your answers in your notebook, put them in the chat, whatever you want to do, see if you can spot them. But starting at the top, we have an early return, which violates the rule of hooks. It's supposed to happen after the hooks, even though we already know that we want to return null if there are no options. Next up, the useEffects dependency array is empty, so the callback isn't going to run when we want it to. Then we're using class instead of class name on the div. Can't do that. Likewise with for instead of HTML4 on the label. And we're missing a key in the options on that loop. I think that's all of them. There might have been more that I snuck in here and don't remember. But that's a lot of errors for such a small component, right? Like it looks fine at a glance, right? Especially if we don't have like error linting set up. Uh, but yeah, it's got a lot of issues. So when people talk about React's learning curve, they're talking about things like this. So maybe we're not so into React. How can we solve the problems from the bad old days by using web standards? Let's take a look at spaghetti code. And I'm going to use a slightly more complicated example than John did. Say, for example, we have an e-commerce site, and when an item is added to the cart, several different pieces of the UI need to update. The spaghetti code version of that would involve calling several different functions to update all of those things. But what if instead we used custom events? Instead of needing to keep track of all the things that need to update when the item is added to the cart, we can just fire off an event that lets anything that's listening react however they need to. See what I did there? Uh, for example, this function has one responsibility, which is to dispatch an event with relevant details. And as feature requests roll in, as we're building the site, we probably won't need to update this at all. Like it'll just keep working. Maybe we need to add more details, but like, in effect, this is all we need. And now that we have an event being dispatched, we can set up other parts of the application to listen for that event. So here we have a couple functions that take care of different details. The update cart button function uses info from the event to update the text of the shopping cart button. And the add to cart function exclusively handles making the API request to add that item to the cart. Neither function needs to know about the other one, nor do they need to know about the function that dispatches the event. Everything is nice and separated. You listen for the event, do what you got to do, and that's it. And the process for supporting other pieces of UI that need to update is pretty straightforward too. Add another function that does only what it needs to do for that piece of UI and set up another event listener. Pretty simple, pretty straightforward. And we can take it a bit further though and encapsulate things a little bit more by using web components. Now, if you look at this code sample, you might go, oh, that kind of looks like old school React. With its like class-based structure, it's got lifecycle callbacks. And we can use these to handle initializing event listeners anytime the component is rendered in our HTML. So here we have a cart button component that sets up the event listener in the connected callback, and that handles all the UI updates. Any cart button component that we render will automatically run that callback, meaning we don't have to worry about reinitializing event listeners when the UI updates. It'll just work. The web component model is a bit different from React, and I would recommend using them mainly for encapsulating this kind of logic, although you can use them as templates. Speaking of which, John is right that manual DOM updates are kind of a hassle to implement with vanilla JavaScript, especially if you need to maintain the same component structure consistently. But I think if we switch up our mental model a bit, we can organize our templates differently and have a little bit of an easier time. Using template languages like handlebars or whatever in the browser is always going to be less performant than making manual targeted DOM updates. So what I would recommend is leaning toward utilizing templates on the server side. The goal here is to create the initial state of the page that gets sent to the browser as HTML. From there, the client-side JavaScript can focus only on changes to that existing structure. So we can progressively enhance features, support interactions, and make targeted UI updates as needed. And my preferred approach for that is data attributes. Basically, anything in the UI that can or should update based on user interactions can have data attributes. This makes elements easier to select with query selector functions, and data attributes are capable of storing information that you can access using the elements dataset property. Like this is a lot better than the old way of like using a class, right? Like this is like a feature dedicated for this purpose. And if you set them up with web components, you can use the attribute change callback to respond to changes to those attributes. Does that remind you of anything? Does that seem a little bit like props in React? Sort of, yes, but you're going to have to write some query selector calls, update inner HTML or text content, things like that. But it's almost certainly going to be more performant than offloading that responsibility to a framework. Not everyone likes working this close to the metal, but by working this way, you end up having more control over what happens. You end up with more maintainable code since you don't have to keep up with framework updates. And anything you write with web platform features will continue to work until the heat death of the internet. All right, back to John to tell me why I shouldn't want to do these things.
All right. So, as Dustin just showed, web standards have come a long way since React first emerged. That's real progress, and we should celebrate that. At Sparkbox, we tend to believe that embracing web standards is preferable whenever possible. But web standards still don't close all of the gaps. So, let's talk about where web standards still fall short and why React or something React-like is still valuable in many cases. So, web components give us encapsulation and composition, but they stop short of offering a cohesive model for building entire applications. So what's missing? To start, web standards don't have a built-in solution for state management. Some mechanisms exist that can help with this. For example, the proxy object in JavaScript, but they're not incredibly ergonomic to use for state management. And they don't have widespread adoption. And they essentially require you to roll your own framework for reuse and scaling. Along with that, web standards don't yet provide a built-in mechanism for reactivity. So updating the DOM in response to state changes is still imperative. You're setting attributes, updating inner HTML, or manually re-rendering whole sections. Now, there are some libraries like lit that do exist to fill the gaps here, but they also don't have incredibly widespread adoption. And again, you can roll your own solution, but at that point, you're basically building a worse, less performant version of React that's bespoke to your project. And in these cases, then onboarding new developers becomes more difficult than adopting a tried and true industry standard. Next, there's no consistent rendering pattern across components, which makes it harder to build and scale applications in a unified way. So each developer team might choose their own approach, be it string templates, manual DOM manipulation, custom templating, or rendering patterns. All of this can tend to lead to inconsistency. Also, with many of these approaches, there's less support, smaller ecosystems, and overall a worse developer experience. When you roll your own solution, you missed out on a lot of the tooling and support that solutions like React provides. For example, React's dev tools, component libraries with drop-in components, and community support. We all know that developers love to reinvent the wheel, but sometimes it's better to use things that are tried, true, and battle tested. Of course, the question still remains, do you always need these things? So I'm going to hand it back over to Dustin again to talk about what tools you might choose other than React.
Yeah, let's start looking at some alternatives, in case I've already convinced you and you're interested in moving away from React. First, we'll start off with a few definitions that will help us evaluate different tools. There are a few major architecture types to consider, including server-side rendering or SSR. This is sort of the Next.js model of rendering HTML on the server and then hydrating, there's that term again, or enabling interactivity on the client side. Static site generation or SSG, which involves generating everything up front, right? All the HTML files, you do that at build time. Maybe there's some client-side JavaScript to enhance some things, but maybe not. And then we have islands architecture, which is really a marketing term that means only use JavaScript where you need it. And this can overlap a bit with SSR or SSG. If I was going to rebrand this, I'd go with something more like sprinkles. Like your website is just a classic Simpsons donut and JavaScript is lightly sprinkled on top. Make it a food metaphor, why not? And now for some rough categorization, right? When we're evaluating tools, it helps to identify where our sites are on the website to web application spectrum. There are no hard boundaries here, but generally simpler document-centric sites fit closer to the website side, and highly interactive dynamic sites fit closer to the web application side. So on either extreme, we have like static info sites, like a small business that just needs a few pages to show hours and location, or really complex tools like Figma that have extremely long sessions, frequent updates, collaboration, multiplayer features, things like this that make it really impractical to build without a framework. And then in the middle, there's sort of a gray area where you can have a mix of static and dynamic content. And depending on the specifics, it could be easier to build either with or without a framework. So with that in mind, when would you not want to use React? More so on the website side of the spectrum, right? If there are only a few things that change in the front end, those things don't change very often, or you have a small team, say 1 to 3 devs, then React is probably too much tool for the job. Also, if you have a small team, you may not have the time available to work through breaking changes as frameworks release new versions. Sticking with web standards helps reduce that maintenance burden, so smaller teams can focus on more important tasks. On the flip side, if you have lots of dynamic, highly interactive content or a large team, 5, 10, 15, 20 plus developers, then it might make more sense to reach for React. It also depends to a certain extent on how experienced your team is with React or other tools, right? Like a small team of folks straight out of React boot camps might struggle with vanilla JavaScript, whereas large teams of experienced developers may prefer a standards-based approach. As always, it depends. Another factor would be whether you're building a site or a component library. If you're building components to be used by React projects, then it's pretty clear that React makes sense. Although, as of version 19, React fully supports web components, so choosing React for your component library might not be such a clear-cut decision. Most other frameworks have supported web components for a while, longer than React. So if you want to support a wider array of projects, web components might make more sense for that sort of thing. All right, let's take a look at some options for building websites without React, whether or not we're using a framework. So I've already mentioned vanilla HTML, CSS, and JavaScript, which are great options up until a certain level of complexity or team size. And this includes web components, by the way, right? That's all part of this. Next up, static site generators. I picked 11D for the headline here because it's my favorite. Uh, these are most useful for things like blogs or marketing sites. But you could use a different static site generator like Jekyll if you like Ruby, or Hugo if you prefer Go. And up to this point, we're not in framework territory yet, right? There's still a lot of overlap with vanilla JavaScript. So you could use 11D for all the backend build time stuff, and then vanilla JavaScript for any client-side features that need it. Next up, we have Astro, which is super flexible and works with a ton of different frameworks, including React. They're the main proponents of islands architecture, which makes Astro sites scale up or down in complexity pretty well. For example, you can have a fully fledged server-side rendered React app with Astro, or a blog that ships 0 client-side JavaScript. Like both are equally possible with Astro. Moving on, we have frameworks that are dissimilar to React, such as Vue and Svelte, which have their own backend counterparts in Nuxt and SvelteKit, respectively. These have some nice quality of life features like single file components and two-way binding. So if that's more your speed, you might prefer them over React. Or if you like React's API but need better performance, there are React-like frameworks such as Solid, Quick, or Preact. Solid and Quick are relatively new and take different approaches to solving some of React's problems. And Preact is more of a lightweight alternative that works best for client-side rendering. If you want to know more about the pros and cons of these different tools, I wrote an article a few months ago that digs into these in a bit more detail. So maybe someone can find that and link it in the chat. So where might those tools work best on the website to web application spectrum? Well, the simpler options make the most sense on the website side, right? With vanilla being a great option to start with. Then once there are more pages involved or CMS integrations, things like blogs, marketing sites, then something like 11e makes a lot of sense. If every user sees the same content, that's a good sign that a static site generator is going to work well. For sites that are hybrids of static and dynamic content, like say a news site that serves the same articles to everybody, but also has some user management features to deal with subscriptions, paywalls, things like this, then something like Astro or even lightweight server-side rendering in a different language, tools like this start to make more sense. And then once you hit a certain tipping point of complexity, or if your team gets large enough, it might make sense to reach for a framework. And once you've opted in, you can build basically anything with one. You just wouldn't want to build a blog with Quick, right? Like that would just be too much tool for the job. We have a nice flow chart to help you decide what tools make the most sense for your project. So feel free to check that out at your leisure. We'll link it somewhere, share it out, but we'll make it available for everyone watching. All right. That's a lot of options outside of React, but even within React, there's some varieties. So I'll hand it back to John to go over how best to use it.
Okay, so let's say you've evaluated your project and decided that React is the right tool. Maybe your app has a lot of dynamic state, frequent UI updates, or it's maintained by a large team that benefits from component reuse and React's tooling ecosystem. So that's awesome, but the question is, how should you use React? First, let's talk about a few of the questions you might want to ask. First, what rendering strategy best fits your needs? So, React now supports multiple rendering approaches, but choosing the right one depends on how your content is delivered and how your users interact with your app. Deciding early how your app will render can be one of the most important architectural choices on the front end. So we'll explore that a little more in a moment. Another question to ask is how dynamic is your UI? Not every part of the site needs to be dynamic and not every component needs to be reactive. So think about how many things change after the page loads and how often. If the entire site is deeply interactive, a lot of your rendering is going to happen on the client side. Examples of this include pages where you're loading lots of asynchronous data, responding to a lot of user events like a page for product configuration or a product listing page that uses dynamic filtering to display different products. But if most of your UI is static, like a marketing page or a blog page, it might make sense to move rendering to the server side as much as possible or use static site generation. In these cases, you can still leverage the benefits of using React as a templating engine with component reuse and all of that good stuff without paying the runtime cost of client-side rendering. And this can ultimately make your site faster for your end users. Another question to ask, what experience does your team have? Always listen to your development team. They have experience, they have preferences based on those experiences, and they can help choose the right patterns and tooling for long-term productivity and sustainability. And speaking of tooling, another question, what tooling and developer experience should you invest in? So React doesn't prescribe a full stack. You have to assemble your tooling, which is both a strength and a responsibility. The tools you choose early will help shape how fast you can build, how easy it is to maintain code, and how quickly new team members can become productive. So let's talk about some of the tooling and frameworks specifically for rendering strategies. Now, in some cases, client-side rendering might be sufficient for your needs. Some examples include internal tools and dashboards where SEO doesn't matter, or single-page applications or admin panels where content is heavily dynamic and user-specific. In these cases, reaching for something like Next.js might be overkill, and you can opt for a simpler solution. So, Create React App used to be the go-to for this kind of simple setup, but now it's officially deprecated, and React no longer recommends it for new projects. In its place, Vite is now a standard choice for client-rendered React apps. It's fast, has first-class support for JavaScript and TypeScript. It offers a great developer experience with minimal configuration. So if you're building a single-page app or you don't need things like routing or server-side rendering, Vite can be ideal. Parcel's another choice if you want to deal with minimal configuration. It supports React and TypeScript as well. And it's great for smaller apps or prototypes or tools where you don't need a framework's opinionated structure. Just keep in mind that it doesn't have the same momentum or plugin ecosystem as Vite. Of these, I would probably recommend Vite. Now, if your app needs server-side rendering for things like SEO and fast initial page loads, then you'll want a framework that supports SSR out of the box. Now, Next.js has been the default choice for server-side rendering in React for several years. It gives you a full suite of tools, file-based routing, data fetching strategies, server-side rendering, static generation, API routes. It's opinionated, it's powerful, it's well supported, but it does come with increasing complexity. And this is especially true with its newer, some of the newer features like the app router model and support for React server components. So there is a little bit of a learning curve there. Now, Remix has been a popular and growing choice in the community because of its web standards first approach to routing, data loading, and progressive enhancement. But Remix announced last year that it was merging with React Router, and its core features are now part of React Router v7. So React Router is no longer just the client-side routing library. As of v7, it supports server rendering, progressive enhancement, form handling, many of the capabilities that Remix was known for. So if you want to keep your stack lean while still supporting SSR, React Router could be a capable and flexible choice. So if your app requires server-side rendering, I'd say the two frameworks to look at now are Next.js and React Router v7. The best fit depends on whether you want an opinionated full stack framework or something more flexible that you can compose into your existing setup. If your page is primarily serving static content, things like blogs, documentation, or marketing pages, you don't need the full complexity of server-side rendering or client-heavy frameworks. So as Dustin mentioned, Astro is purpose-built for static sites. It uses your content to render static HTML by default and only loads JavaScript where it's truly needed using the islands architecture that Dustin described. With Astro, you can write your components in React and only hydrate the interactive parts. Everything else stays lightweight and fast. And this is ideal for content-heavy sites that still need bits of interactivity. As a bonus, Astro also supports frameworks other than React, including Vue, Svelte, and Solid. So Next.js also supports static site generation and static export, which let you pre-render your site at build time. This is great if you're already in the React ecosystem and want static performance with the option to scale into dynamic features later. It's not as optimized for static first use cases as Astro, but it works well, especially if you want to stay entirely within React or you want to use a combination of rendering patterns. So there are lots of options out there, but ultimately your choice in tooling should reflect the needs of your application, how your users will interact with it, and how they will consume your content. With our clients, Next.js does tend to be a popular choice because of the flexibility it provides, and we're often building sites that use a combination of these patterns. For example, we have one client project that has different features that require different rendering mechanisms. It has an admin section where a lot of the initial data is rendered server side using React server components, but it also requires heavy user interaction and dynamic data loading, which is done in the browser after the initial rendering. This site also includes a questionnaire section where questions are dynamically presented based on previous answers, and the transitions between questions are handled using the link component in Next so that the transitions happen entirely on the client, which feels faster and more seamless to users. So we have another client whose site includes a lot of static marketing pages, which don't need to be updated frequently. And so these pages are generated at build time using static site generation and are served via Netlify, which allows them to leverage Netlify's edge node caching, meaning that these pages are super fast across the globe, regardless of the user's geographic location. But this site also includes some sections that are driven by a content management system where content changes frequently. And for those pages, we leverage server-side rendering so that the content specifically on those pages can be frequently updated without requiring a full site rebuild. So again, these pages are still served via Netlify, and we can leverage all the edge caching and all of that good stuff. But we provide a revalidate interval so that the page can still be frequently refreshed with new content. So as always, it's important to choose the right tool for the job. And so with that, I'm going to go ahead and turn it back over to Dustin for some final parting words of wisdom.
Yeah, thanks. And this may be a surprise coming from me based on all of the things that I've been talking about, but we are not recommending that everyone go and rewrite their React apps right now. Rewrites are expensive, time-consuming, and most likely not worth it. Unless there are like fundamental problems with your site that, it would be worth it to, start from scratch anyway. You're better off sticking with what you got. Uh, so yeah, don't take our take our advice and just rewrite everything. I also mentioned newer frameworks like Solid and Quick, but you may have noticed I spent a lot more time talking about vanilla JavaScript and web components. If you're evaluating tools for a new project, it's worth starting with the web platform first and seeing how far that will get you. Frameworks are great, but they're not built to last in the same way that web standards are. At the very least, picking tools that work with the grain of the web rather than against it will make life easier in the long run. Uh, Also, don't just go and use 11D because I said that I like it. If you have the luxury of time, kick the tires, try some different things out, and see what works best for the types of projects you work on and the type of team that you have. If you have time at the start of a project or between projects, you can try a bake-off. This means building the same thing with two or more different approaches to see what works well and what different pain points emerge with different tools. What you should try to avoid is just using the same tool for everything, regardless of whether it's a good fit. Next, whether you continue using React or some other framework, measure performance and optimize what you can. Get comfortable with the performance tab in DevTools, and maybe even get a cheap Android phone to test your websites under real-world conditions. Whatever tools you choose, make sure that you're using them well. And lastly, everything changes all the time. Frameworks rise and fall, paradigms shift, leading to even more tools and jargon over time. Is React still going to be widely used 10 years from now? Or Solid or Astro? I don't know. There's a non-zero chance that none of the specific tools we mentioned will still be relevant by then. Uh, However, I'm much more confident about web standards sticking around. The web is incredibly backwards compatible, and we've gotten a ton of great new features recently that we'll be able to use going forward effectively forever. I use RSS to subscribe to a bunch of developer blogs and newsletters, which is how I keep up to date with new web features like popovers or CSS anchor positioning. You can do the same or follow other devs on social media. Not me, I'm not there, but whatever helps you keep tabs on what's new to the platform. And then in the course of your work, you'll be able to recognize when there's a new HTML feature or a CSS property that can solve your problem, rather than falling back on an old JavaScript or framework specific fix. As John said, it's all about using the right tool for the job, and keeping up to date on what's out there will help you identify those tools better. All right, that's all I got. So on behalf of John and myself, thank you for attending. Thanks for watching.